Okay, so fixing all these bugs. I want to undo all of this, bring us sort of back to where we started with. And now grid, let's see. Right, so grid query mute. So we want to probably put this back to just a query and not do query mute anymore. So let's see, this is still in the camera, this is still all inside of here. Then game object draw. Okay, so I think at this point, game object is attempting to do mutable things. So let's go take a look at that. Inside of draw. So if I basically put you back to here. Put you back to here. Our draw system is attempting to mutate things. So that's the next. Let's go see if we can find our draw system. So we don't want you to be mutable anymore. Right, because we're storing like all of this stuff. So what I'm thinking is we change this around. So instead of like switch walk every and like basically keep on calculating when the next time we want to change this, I'm thinking that we just basically measure the ticks and go off of that, which is a little bit of a hacky way, but it will make it so we don't need to mutate state, and that will like really help out with those basically the mutes, and the problem that we're running into is that we're borrowing one thing as mutable already, so to borrow it again as mutable causes a problem in Rust. So an architecture change is needed to make this work the way I was sort of hoping to work, and I'm really thinking that state change here probably isn't the right place, or if it is here, having draw be owned by the player maybe not the best of ideas. But basically we can switch walk every, so what I really want is the two different, probably just to store like the walk 1 and the walk 2. So over here we can have like basically the walk 1 every, and this could be whatever a tix is. I think that's like a U64. Walk 2 every U64. This is a little bit of a violation of solid because it's basically this struct being aware of how the rest of the game works and how the game engine is doing stuff. And we really don't want that to happen. We really would like this to be, you know, solo on its own. But I couldn't figure out a way to do this without a big giant refactor. So this is like how to fit it in. It's a little bit of an evil. Okay, so then here we can take you away. I want you to be, okay, so walk 1 every, if I say that I want you at, like 9 ticks every 16 frames, so like it's, every 1 second is like, so, okay, so if I do 9 Oh, if I do something like 20 and then walk 2 every can be 10. Okay, I think that would work. I want to do the 20 first because if I check to see, hey, are we a is like 20 modulus the number of ticks? Is that if that's 0 or modulus ticks modulus walk 1 every. If that's 0, then we know that we're based upon number 20. I forgot the right word for that. But 10 obviously and 20 go together, so maybe this would check this one first. Although then check this one. So that would be like 10 would skip this one, go straight to here. 20 get this one. 30 would get this one, and so on. Send and draw here. So okay, reference to self. So we don't do all of this stuff. It's figuring out what. Okay, so this is figuring out which of the meshes to use for this draw. So it's like returning into mesh here. So that mesh equals. Okay, so there's that. And what we're gonna want to do is switch you over, so we don't need we don't need this. So switch walk at, walk one, switch walk at. I think I can just replace all of this stuff here. Okay, so if we're in a running state, we want to get the ticks. And I think we can get that out of timer, which we don't have in here. Okay, so timer, ticks, pass it context. Oh, this is a U size, so we need to convert U. Okay, so we have the tick that we're on. It's a U size, so it's going to be like 0. I think it doesn't start with 0. I think it starts with 1. We probably want to start. We want to start with 1, right? So like, if you're because if we start with tick 1, that'll be up until like tick 10. Oh man, because I don't want to switch that off. Okay. If I divide it down, I basically want a way to like stateless figure out which one we're in. Like, are we in tick 0 through 10, 10 through 20? Because if I just do something like here, we can switch it out. So if I just say, okay, we're in, and this is grabbing the appropriate mesh from here. Let's say if tick modulus 2. So let's say if you're even, then we're gonna want to return, let's say like jumping 1 or walking 1. Otherwise, return player walk 2. All right, what are you upset about? Expected a tuple, found a reference. Oh, right, because this is the offset of what it is. So, tuple. All right, so let's go find what these last two errors are. Right, so game objects get mute. This is all in, okay, so query mute. So we can get rid of query mute because we're not using it. All right, no errors. Let's see how fast the legs sort of move. I have a feeling it's gonna be way too fast for our game. I mean, it's not terrible, but it is a little bit fast. We can see, oh, when it goes into the end state, it still has like the running animation. So we do want this to sort of slow down a bit. So we want to like go with one, and then the other, and then the other, and then the other. Let's see, what things could we do to sort of like figure out how to do a storage? So we could use a channel and basically not have that outside of here. Can we have this in meshes? Could like the meshes itself be aware of time and context? And if so, where would that end up being? I mean, we could do an update, right? In update, we can choose which mesh to use, and maybe that would be a good idea. So like in draw here, so we have our draw trait, which is just draw. We could have an update for it. If we have an update, that would potentially allow us to update these. Let's try it. So if I have a function update, we mute ourselves. Let's say we don't even need the meshes. We don't need any of the other stuff. Let's see. We might need the context for the timer. I don't even think we need the location. We probably want to know our state. So like our physics state, if we're aware of that, then we'd be able to like switch that around. Let's start with this. Then we're not going to return anything at all. That's just what we're going to have. So down here. Okay, so if I want to do this, then we can come back here and change this again. So we can go, maybe we can go back. Let's do this as an experiment. Let's just try like walk like switch walk at, is it duration? Oh, switch walk every. is iterations. Let's do this up here. Let's do 250 milliseconds. Gives us that. And then we'll have our switch walk at. So if I do this, or then we could do, okay, so switch walk every. And if we want a switch walk at, which would be an instant, so I want an instant now. Okay, so give me now, and then add switch walk every. So you're sometime in the future, and then we're going to store you away. Okay, so that if I want to like just print out in some kind of like update, so switch walk every, switch walk at. And it looks like we may not need the context at all. Because I might be able to just do, what would this be? We could just debug, debug switch.walk at, switch to walk every. Okay, so debug you. Now if I reference you, I can then use you and then update you so we can see those numbers going up. So if we get another instant now, okay, so if now is greater than or equal to switch walk at, then this is where we would sort of like set next walk animation. Yeah, so like we want to like probably set what the next walk animation is going to be. And then add to the now. So we're gonna self dot switch walk at. We want to now reset that to now plus every. Okay. And it looks like we don't need the context. Okay, so that gives us an update in the player's draw. And I think only the player has a draw. We can go take a look at that for certain here. So game object, here's our draw system coming here. Chantilly, good morning. So yeah, it's determining if we have a draw system, do that. Otherwise, do this other thing. In our main library here, I believe up at the top we say use, so where's the player? Okay, so create player. Oh, it's because we have a create player method here. Here it is. So where's the draw system? Okay, so physics is the, okay, here's the draw system. Sum, new player, new draw. Okay, so we create the new player draw. Then in update for this, for the entire game, we're gonna want to call, let's see, tell the grid to update the draw systems too. So we can see that that's happening in grid update. So if you come here to, okay, so this is just a self move game objects. Now this wouldn't be moving the game objects. This would be running the grid update system. So we can maybe implement that here. So we can loop through all the game objects after we've moved them on the screen and like handled all the movement and everything else. So so iter, we're gonna have to do an iter mute for this. Okay, so we're gonna get our game object ID out of this. Then we can check to see if we have a draw system. So objects dot draw system. Oh, it's draw game object dot draw system. Okay, so then we've extracted out the draw system. So what are you upset about? Cannot move. I don't want to move you. I want to get a, what is this? Mute ref? Or is it ref mute? Or as ref mute? Oh, it's ref mute. Okay. Then we now have our draw system. We can now run update on it. Like that. And your draw system. No errors. Let's see if we see those debug logs come out. Okay, so we can see the walks going. They are changing. Yeah, every 250 milliseconds, it looks like they are changing. Okay, so that's good. What does that mean for us? Then up here, switch the walk animation. So we're gonna want like walk animation 2, walk animation 1. So what does that look like for us? In player draw, we're gonna walk so walk animation 1, and this can be a Boolean. Let's say for this that we're gonna start with true. So we're gonna start with 1. And then down here in our update, we don't need to debug anymore. We know that we're updating this, but what we can also do is walk animation 1 equals the opposite of self.walk animation 1. Okay. So switch that around, it'll go back and forth. And then inside of our draw here, we don't have to do any calculations anymore. Now it's gonna be, well, I guess like there's a little tiny bit of logic. It'll be, We can just do a match. I wonder if it would make sense to do like a match here. So a match on self dot walk animation 1. If we have true, then we want to return. So let's wrap this entire thing inside of the tuple, and over here we'll have our 0.0. And here, okay, so if we are true, we want, let's see, meshes.player walk 1 with false, meshes player walk 2. Okay. Not the nicest looking code, but I think this gets the job done. Let's see if this decreases, like makes the run a little bit slower. And then we have a little bit more control over it. We do. And it stops updating at the end, which is nice. That's kind of what we wanted. Now, one problem here, that was a little bit too slow. So we can just tweak these numbers just a tiny little bit. That's in our draw system here. In update. Not an update. In new. So instead of 250, we want you to be something like 100. Yeah, that looks about right. So basically using the update pattern was what we needed to do. And that way we can have our state updates, but not necessarily worry about having like mutate self all over the place and sort of like change everything else. Just separate that out. That was the way to go. It is running, it is nice. Okay, so last thing, when we're in draw, I don't know if it's the actual last thing, but we'll find out. So when we reach the end, we probably want to go back to standing or something like that. Let's see, and physics state. I guess there is no physics state in this, right? We really would like to know, because we have the physics here. We have the context, we have the location. We don't have the game state. It would be nice to pull in the game state, and then we can sort of bring the player back into like done mode. That might be nice. Let's see, so in the main library, we have, I think the game, we have state in here. So we can pass that through. So let's update our trait first. Okay, so we're going to bring in a reference to the game state in draw here, which means we need a reference to the game state here. Then once we have that, okay, so this is the mesh off of here. I probably want to mute this. Oh, mute must be attached to each individual one because it's a tuple. So we want mute on the mush, mute on the mesh. Then down here, okay, so we have draw. So before we draw, we want to determine should we, based upon the game state, like should we be changing that? Okay, so what would that look like? If let game state end. Can you not find that? Oh, states, that's what I called it. Okay, so, oh, it's a 1. Game state 1. Okay, so if we won game state, then let's reset, like change our mesh here. So mesh is now going to be equal to meshes. I guess we can just do player standing again. And we can actually do this as sort of like a little jumping thing. So like once we get into here, we can do a very similar thing here. So let's do mesh equals self dot walk animation 1. If it's true, then okay, meshes dot let's do player standing. Okay, and then meshes player jumping. You need to be okay, equals match off of you. Okay, that updates our mesh, then it should switch back and forth between that. If we're calling this draw every frame outside of like the game's, while the game is playing or outside of playing, and I don't actually think that we are. So we may have to refactor that too. But that being said, let's see. No item associated with gameplay 1 with game state. Really? Wait a second. What am I missing here? Game state. It's. Oh, because it states. Hold on, not game state then. We want states. 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 And now you can be states 1. There we go. Okay, so then a couple errors here. Let's go and find those and fix them. Right, so when we're doing our draw system, now we want to pass in a reference to the states. We're in game objects, so we need the state in here. That, okay, and then we need to pull in states. Okay, then in camera, we need to pull in, for game object draw, we need to add in the state, which means we need to bring you in too. Matrix 17, good morning. And then here in the main library. Okay, so then we have the states. We just need to add this in. Stop that state there. And we need you to be a reference. There we go. No errors anymore. So let's see if this works. I don't think we're gonna have the player sort of jumping up and down at the end because I don't think that it's updating. Oh, I need a win. Yeah, we're not calling the update here every single frame. So if we take a look in our main library, yeah, so while we're playing, we're doing this grid update. So what I really want to do is have a separate graphics update, and then we can call that all the time. So let's go ahead to our grid and refactor this out. So we have this update, and we're doing this here. Let's add in a. This is going to be sort of like a graphics update. And I don't think we need anything else for this. We're just going to pull you down here. Like that. Oh, we do need the game objects. So I don't think we need you with lifetimes. Okay, so we just need to reference the game objects. We might need you to be, yeah, a mutable reference to the game objects. And I think everything else is gonna work with that. So let's go down to graphics update here. So none of this I don't think needs to change, but in our update, regardless of which state you're in, so we have this self.camera update, we're gonna do self.grid.graphics update. Hand it the mutable game objects. No errors. All right, let's see if that works. There we go, and we get our little player sort of is happy and jumping around as soon as they live and they die. All right, let's what else do we have in here? So we have standing when they're starting. They have running. We can fall off and die. Oh. Come on. We can die on the spike. All right. I think this is a game, and it looks a lot better. Now we have we can switch out a lot of these other things for various different images if we have them. I don't have anything ready, so I don't think I can necessarily do that right now. But we have the basic game going. So if I were to actually make a real runner, there'd be some slight differences that I would want to sort of play around with. I think for one, I might want to separate out the draw and the updates completely. Have like a draw system that takes in the game objects, and so it reaches in and says like, look, give me your location, give me each game object, and I will draw you. And then that way, that could be like completely separated. The game objects don't even have to care about how they're drawn to the screen. One really positive about that I might be able to get away with is having the game objects be in a different thread, like the draw system being one thread and the update being a completely different thread. Because we have like location that's being mutated in one and not in the other, they would need to be in arcs. So we'd need to, if we were to use threads, multi-threaded game here, that would definitely be something we have to look into and like be very cognizant about how we're going to structure and pass that mutatable data around. So definitely arcs would, and arcs and what's the thing that goes with the arc? The mutex. Arc and a mutex together would be necessary to like update in one and then read in the other. Because I wouldn't want to create a thread for every game object. I would want a thread for just all of the updates. Okay, so there's that. Probably I would want to start with some kind of graphics to begin with right away. Right now, we wait until the very end to put in any kind of sprites. And because of that, it sort of made things a little bit like, I think we would have seen changes to make earlier on. So where is this? In meshes here. So I probably wouldn't have like meshes. I would probably have some other, like probably name it something else. Maybe like sprites, maybe something else. I could potentially also do this as an enum. That way we have like our floor and it holds like the mesh for the floor. And so maybe I could have like images or like the draw system wraps around these meshes and understands like, okay, this is what the floor looks like. This is what floor 1 looks like. And this is what that's called. And if the game object has the enum of the title of that, we know what to use. So I think that would be good for us to do. The graphics then would probably be in charge of handling that running code. So instead of having like a draw system that we put into the game object, that would be maybe a draw system that goes in that's like separated out. So we can have like all the draw systems essentially in a vector. Or another hash map. Like, okay, let's get the ID of the player out. Let's now get the ID, like let's now reach in and grab the draw system for that player. And so that brings us a little bit closer to an ECS system where we're separating out all the data and all the logic and everything else. And we're basically just walking down the line. Like, okay, give me all of the like information that I need for this one and like thin vertical stripe. Maybe we'll have less CPU cache misses. I don't know. We'd have to play around with that. Certainly the game that I was making here doesn't necessarily have a big problem with that. Now, if I were to try to make this have an absolutely huge level. So let's go and find game data.json. So if I just replicate this. It's like go through here. A couple times. So we've not quite tripled, but made it significantly longer. If we run the game now, and this is in debug mode, it's still pretty much the exact same sort of feeling for this. Something else in a real game, having the editor either in place or like maybe a website that you can go to sort of like set up what the levels look like would be really nice. Because then I could just drop in the new JSON file and then try that out. And everything is still working exactly as we want. And that's the power of using this game data JSON file outside of the game is I don't need to recompile this. I can just keep on running this with a different JSON file and it will work beautifully well. Out of curiosity, because I haven't tried this before, we have these resources inside of the target. If I compile this for production and I like want to bundle it and actually like get to like deploy this to somewhere, what would that end up looking like? Let's do a let's build this for a release. Let's like move it to my desktop or something, or outside of here, and try running it and see what that looks like. Now, of course, I'm on Windows here. If I try to actually put it onto Windows and like run it, it will yell at me saying, hey, you don't have this signed by like Windows. So therefore it's probably some evil thing. I'm not sure how to add a signature into these builds with Rust. That might be something else to look at too. So here we're in target release, so it should be very similar to where we have our GGEZ runner 2 here. We're going to be getting one as soon as it finishes compiling in here too. Okay, so here you are. If I copy you over here, that is, oh, okay. I was gonna say that's really slow. Just, I guess, took it a while for it to decide what was supposed to be happening. Now, I shouldn't be able to run this yet because it shouldn't be able to find the resources. So I probably need to drag these in. Oh, you don't want to be dragged over here. I can drag individuals. So hold on, let's. Oh, that was just one of them? Yeah, that was just one of them. Okay, so let me try copying on your side. So where is this? Where this is in targets. Debug. Okay, so can I copy, how do I copy resources to I guess I just want to start from the beginning. So like C okay. Desktop? Yeah, okay. Oh, CP doesn't exist. Okay. Is it just is it full copy? Yes. Okay, that put all of these over here. I was sort of hoping that would put the like each individual, like the folder in here. I guess there must be like a copy folder. Okay, so like let's create a new directory. Call this resources. Throw you all in here. And if I try, oh, one more thing that we're missing is that that JSON file. So let's now copy. What did I call this? Game data to JSON. Okay, so here's our game data to JSON file here. If I try to run you, it should yell at me saying, yeah, don't run. Go ahead and run this one anyways, it's mine. Hey, okay, it worked, and it found the little bunny. Okay, perfect. Now if I like put game data, let's say I delete game data, you should crash, right? Yeah, it didn't even run. Like, it just crashes instantaneously. Let's put it back. So it's searching for the resources in the same directory it is. It's searching for game data here. If I were to bundle this up into like a single folder, so let's add you. This would be our runner. Throw you into here. And then I want to, that's really big. I want to take you and like maybe put a create a shortcut on the desktop here. So this would be like the equivalent of, okay, we have like I have a launcher or something. I want to run this. Here we go. Here it's running. We have this in the background. That's not the best, but it works. So if I wanted to use like something like this for maybe like a Ludum Dare game, this would definitely work. And this is how I can get it out to Windows users. I just have to let them know, hey, I don't have a certificate, so sorry. You'll need to figure that out yourself. Sound is something that would be really nice to add in as well. I think that would be very similar to the audio stuff. So we'd want maybe like a similar to like meshes, have like audio, maybe have like an audio thread, and maybe deal with that separately as well. So that way we have like update. I guess like an inner updates. We have updates for graphics, updates for physics, updates for audio. That might be it. Like physics, audio, graphics, and then draws. Well, you're just drawing the. Well, it's just drawing. Yeah, I think that would work. So, what I kind of want to do is take this and I don't have a I keep forgetting, like in Mac I can archive it, but that doesn't come in Linux type stuff. Let me see if I can do that over here. Let's see if I can zip it up inside of the Ubuntu. So we have our runner here. I want to zip you. Do I have zip? I don't have that. Do I have, I can get you. Sudo apt. What am I even using? I don't remember. Ah, I remembered the password. Okay, perfect. Okay, let's go ahead and see. Sudo apt search zip. Okay, so there's just zip. I could just install that. So apt install zip. Main use of WSL is using zip instead of like 7-zip or something like that. All right, so if I want to zip, how do I? It's been forever since I've used that. Let's see. So the archive, input, in path, okay. Okay, and then I can do -r. Okay, so zip -r. The file is going to be runner.zip, and then what's coming in is runner. That adds that there. So here's our runner archive. If I were to like open this up, we should be able to see all the files in here, and it's going to create the folder runner in it, so it's not just going to spread everything out, which is nice. Hopefully it won't create like a runner. So let's test that out. If I delete you, wait, did that create runner? Oh, it did. It created a runner. That's funny. Not optimal, but I guess I don't know. Maybe it's just me from using like tar a lot. I would probably prefer, yeah. If someone uses manual zip with this though, it's gonna like spread out if I don't do this. So I'm gonna keep this and just like, that's, you'll figure it out. Let's now add this in. So we have our target, we have our source. Let's go ahead and create like a build or like deploy. And I'm going to store this inside of GitHub for right now, which should be perfectly fine because it's not too terribly big. How, like out of curiosity, how big is this? You won't tell me. Let's see. 1.4 megabytes is how big this is, and that's with these images that are not optimized. Like they were really big, and we could have scrunched them down a lot smaller, and it would work a lot better. So if I now open up Git Kraken, we can now save this, push this up, and you could essentially download the runner.zip and play the game on your own computer if you have Windows. You'd have to compile it if you have, Mac or Linux. So this is going to be like finished basic game. that. Push you up. I have a link to all this code here at Bang Repo, and if you're watching the VOD, I'll put the link to that code in the description to the VOD. So if you want to go play it around, take a look at the source code, tweak things, rebuild it to sort of see how it looks, you are very welcome to. If you want to try like implementing the rest, like other sprites and images for like the ground or the start or finish, anything like that, that would be really awesome to see if you take like a screenshot and tweet that at me. Let's see, what's anything else they want to do with this? I want to see if I can compile this for Linux here. Okay, so here we are I'm on the WSL. We can't run this inside of, we found that out because the graphics side isn't working properly. Maybe the WSL2 will work a little bit better for us, but I wonder if I can build this. So if I can just do cargo build in develop mode, will this work at all? If it does, I might be able to also put in like the Linux build of it as well. And then all that would be left is figuring out how to compile for Mac, which, I mean, the cheating way is me to just like download this on a Mac and build it. Like that would definitely work. But if I wanted to figure out how on Linux or Windows to cross compile for a Mac, that'd be something slightly different. So I have like 10 minutes left before my normal like end time, and now that I'm no longer in vacation mode. Do any of you have any questions? Okay, so we can compile this. Let's compile in release mode. And then I can, not from you, Chantilly. It's okay, I know you're not a Rust developer either, and you haven't really done too much game dev. But I'd love, if you ever build anything, let me know. Yeah, so it looks like I can compile this. I can't run it here. I'd have to transfer it over to my Linux computer over here and try that. So maybe I'll add this to the Git repository, and we'll play with that as well. So let's see, I actually want this to be inside of here. Okay, so we were able to finish the optimized release build. Here's our sort of like the build. Go in here. I'm gonna move, so remove runner.zip, and let's make this now runner windows.zip. We want to create another directory. Actually, we want to just go into target. How do I do this? I want, if I add into zip, it's gonna like want to do weird things when I like pull them back out again. So let's copy. Where am I? Oh, I'm in build. All right, let's copy from target. Okay, so we have debug, release, RLS. Oh, okay, I know. I'm gonna cd into target, release. We build. Okay, so here's our GGEZ runner 2. And okay, so here's our GGEZ runner 2 that's not an executable. This is the Linux one. That's 8.2 megabytes. Whereas you're 3.5 megabytes? It seems a lot more. Okay, and then if I want to bring in the JSON file, so copy game data JSON to here, and then copy, let's see, this is gonna be the debug resources to here. Okay, so now I have resources, I have examples. Let's now, so zip, I'm gonna put you, not there, one more back. Okay, so in build, and this is gonna be in our Linux, so this is gonna be runner linux.zip, and we're gonna pull in GZ runner 2. Oh, this is gonna put it into the same directory when you unzip it. That's not cool. I don't like that. Hold on, let's go back out one. Let's try this again. Okay, runner like zip 2, we're gonna pull in release GZ runner 2, release the game data.json, and release resources. Okay, so that adds that all in there. If we come back out, okay, here's our build. The Linux is double the size of the Windows one. That's really fascinating. I wonder if it's just the libraries that it needs, and like why that ends up being so much larger. Still a nice small game, but let's go to get Kraken. So built game for Linux. And push you on up. Okay, so if you have a Linux machine, you can now play it there too. Mac is maybe going to be a little bit more interesting to play out. I tried once before. I need some like major libraries because Rust is static linking, meaning it pulls in those libraries and like adds them to the binary, as opposed to just saying, hey, look, I assume you have these libraries in your system. I'll reach out and dynamically grab them in at runtime. Which like you can argue is good or bad. For Rust type things, you can guarantee it's going to work because you know, hey, we have this like a very weird version of like some kind of library, and now everything doesn't work. But not a problem for us. So with that, I think I'm just gonna mark this adventure through game programming patterns is done, and I'm gonna put a close marker. So this is going to be the end of the YouTube video. For whatever is coming next on YouTube wise,